Hi viewers, in today's video we'll be differentiating the following functions, which is y is equals tan x and y is equals square root of tan x. These are two things. The reason why I brought this question is we need the first derivative for to solve the second question. So without wasting much of your time, let's just get straight to business. Solution. That's for the first one. Now recall from our trigonometric identities, we said sin x over cos x is equals tan x. So this identity will be very important for us in this video. So we'll be replacing, for the first question, it says y is equals tan x. But instead of tan x, recall from trigonometry that tan x is this. So I'll be replacing sin x over cos x in place of tan x. So I'll be having sin x over cos x. You see, as you can see, I've changed the nature of the equation right now because it was tan x, but right now I have sin x over cos x. I recall from the last video I did about quotient rule. I said when you have two functions, a function over a function, we'll use the quotient rule. So something is applicable here. So to solve for this, we all know that our u is going to be sin x, our v is going to be cos x. In case you've not watched the video on quotient rule, recall I said you can check it on the link below. So we have y is equals u over v. So when I have functions in this form, u over v, I'll be using the quotient rule. So we have our u to be sin x because that's what I said, our v to be cos x because this is what I said. So now to differentiate our u now, because we need du dx, our du dx is going to be the derivative of sin x, we said is cos x. We still need our dv dx. The derivative of v, which is cos x, is going to be minus sin x. So we have everything, and recall that the formula for the quotient rule states that dy dx is equals v du dx minus u dv dx, everything over v squared. So we have everything. We have our v, we have it, we have du, we have u, this is it, dv dx, we still have it. So I think the formula is ready now. So everything is going to be v, which is cos x, we are multiplying by du dx. Our du dx is still what? Cos x. Then minus our u is sin x, so I'm having sin x, then I'm having dv dx, I'm multiplying by dv dx, which is minus sin x, then everything divided by v squared. And recall that our v is cos x, so I'm having open bracket cos x all squared. So we've substituted for the whole thing we brought out of the equation in the formula. So the remaining thing now is just to simplify this down. I'm going to have cos x times cos x is going to be what? Cos square x. Minus, and this minus that's in the bracket becomes positive. So sin x times sin x, that's sin square x. Everything over cos square x. But still recall from our trigonometric identities, it says cos square x plus sin square x is same thing as 1. So we'll be using that here also. So I'm having dy over dx, which is this, is equals, in place of, recall what I said, cos square x plus sin square x is same thing as 1. So I'll be putting 1 over, I'm having cos square x. Alright, cos square x. So going back to trigonometry again, there's an identity that says 1 over cos x is same thing as what? Sec x. 1 over cos x is same thing as sec x. So when it's 1 over cos square x, it will be what? This is going to be sec square x. I'm putting the square because the cos was squared. So this is the derivative of y is equals tan x. So for the second one now, for the second one, which says y is equals square root of tan x, y is equals, we can write this as tan x raised to power 1 over 2. Because anything raised to power 1 over 2 is same thing as square root of that function. So I'm having tan x raised to the power 1 over 2. So looking at this, the question is already telling you that you are to use the chain rule. So using chain rule, we let u is equals what is still inside, which is what? We have our tan x. Now how do we differentiate? The reason why I said the second question needs the support of the first question is we need the derivative of tan x right now. And recall that we've already differentiated tan x, which is what? Sec square x. So right now, du dx, instead of suffering to do all this, we've already gotten it to be what? Sec square x. So I'm going to have sec square x as my du dx. So right now, since I said y is equals, I said the whole of this is u. So I'm having u raised to power 1 over 2. So how do we differentiate y? Just normal power law. Sorry, I'm supposed to say dy over dx is equal, sorry, it shouldn't be dx because I'm differentiating in respect to u, so it should be dy du is equals, bring down the power, which is 1 over 2, u, we bring it back, remove 1 from the power, because recall from the rule says x raised to power n is equals n x n raised to power minus 1. Then I'm having half minus 1, which is equals 1 over 2 u raised to power minus 1 over 2. So this is our dy du. So recall that our chain rule states that dy over dx is equals dy du times what? Du dx. We have everything. We have our dy du, which is this. We have our du dx. So everything is ready. It's just substitution that's remaining. Dy over dx is equals dy du, we said, is half u raised to power minus half times what is du dx? Our du dx is sec square x. So I'm having sec square x. So right now, recall I'm saying dy dx, but I'm still having u, which means I have to bring back everything. And recall that I said let u to be tan x. So in place of u, I'll be putting tan x. So I'm going to have 1 over 2 tan x raised to power minus 1 over 2 times what? Sec square x. Sorry, I have to continue this side. Now our dy dx is equals half. Anything raised to power, when I have x raised to power minus 1 over 2, same thing as saying 1 over x raised to power 1 over 2, positive. So I'll be doing same thing for this one. I can say 1 over 2 times 1 over tan x raised to power 1 over 2. Look at, I just brought this down. So 1 over 2 times 1 over, because it's negative, you can see that I have positive now. Then I'm having times sec square x. And right now I can still make this to look like dy dx is equals, I'll bring my sec square x back. Sec square x times 1, I'm having sec square x over, now 2 is under, which is 2 tan x raised to power half, we said the same thing as saying square root of what? Tan x. And that's the derivative of square root of tan x. Just